Hey everyone, and welcome. Today, we're grabbing our virtual magnifying glasses and diving headfirst into the absolutely incredible microscopic world of crime solving. We're talking about trace evidence, those tiny, often invisible clues that, believe me, can tell a surprisingly huge story. Let's jump right in.
And hey, before we get into the nitty-gritty, if you enjoy these deep dives, do me a favor and hit that like button and subscribe to Smart Tutor. It really helps us out, and it's the best way to make sure you never miss another explainer. Okay, now let's get back to the scene of the crime.
Every field has its golden rule, right? And in forensics, it's this beautifully simple concept that is the foundation for everything we're going to talk about today. It's the idea that, well, nothing happens in a vacuum.
And here it is, Lecard's exchange principle. Basically, it means that whenever two things touch, they trade a little piece of themselves. Just think about it for a sec. If you brush past someone, maybe you leave a few tiny fibers from your sweater on their coat. But a violent struggle? Whoa, that could leave behind a whole world of evidence. The intensity, the duration of that contact, that's everything. This one idea from a French forensic pioneer named Dr. Edmond Lecard completely changed the game. It revolutionized how investigators even approach a crime scene. Suddenly, they weren't just looking for the big, obvious stuff anymore. They were hunting for the microscopic fallout of every single touch.
So where do you even start looking for these traces? Well, some of the most common and, frankly, most powerful pieces of trace evidence are the very hairs and fibers that we're all shedding constantly, without even thinking about it.
I mean, a single hair found on a victim's shirt, or one carpet fiber stuck to a suspect's shoe. These can literally be the threads that tie an entire case together. They're like tiny, silent witnesses. So to understand their story, let's start by taking a closer look at hair.
Okay, now this is a really cool way to think about it. A hair isn't just one solid strand. It actually has three main parts, and this pencil analogy is just perfect. Right in the middle, you've got the medulla. That's like the pencil's lead. The main part of the hair, the part that holds all the color, that's the cortex. Think of that as the wood. And then that outer protective layer of scales, that's the cuticle, just like the paint on the outside of the pencil. So, put yourself in the shoes of a forensic examiner for a second. A single hair is brought to your lab. Before you can even begin to think about who it came from, you have to answer a much more basic question. Are we even dealing with a human here or an animal?
And this chart shows exactly how they can tell the difference. On a human hair, those cuticle scales are flattened and they overlap, which is a pattern called imbricate. Animal hair can have all sorts of different patterns. But here's the real kicker, the medulla, our pencil lead. In us humans, it's pretty thin. Sometimes it's not even there. But in animals, it's usually super thick and continuous. That right there is often the dead giveaway.
All right, so we've confirmed the hair is human. Now the real detective work can begin. The investigation zooms right in on the cortex. Remember, that's the wood of our pencil. This is the part that holds the pigment, the tiny little specks of color. How those specks are spread out, their texture, how many there are, all of that becomes super important for comparing a crime scene hair to a sample from a suspect.
Now, the cortex can also give some very broad clues about a person's ancestry. And I need to be really clear here. These are not definitive, set-in-stone categories. They are just general observations that can sometimes help narrow things down. For example, hair of European ancestry often has an oval cross-section with evenly spread out pigment. Hair of Asian ancestry tends to be round with really dense pigment. And hair of African ancestry is often flat or oval-shaped with dense pigment that might even be clumped together. Again, just generalities, not a foolproof ID method, but it can give investigators a valuable lead.
Okay, let's switch gears from hair to fibers. You've seen it on TV a million times, right? The brilliant detective finds one single unique fiber that just cracks the whole case wide open. So that's how it works in real life, isn't it? One perfect match points to one person, case closed.
Well, not quite. See, the huge challenge with fiber evidence is that fibers are mass-produced. That blue cotton fiber from the crime scene, it could have come from thousands, if not millions of different blue cotton shirts out there. So it's not about finding a unique match, it's about building a case. The more fibers you find that match a suspect's clothes, the stronger that link becomes. And if you find a cross-transfer, that is, fibers from the victim on the suspect and fibers from the suspect on the victim, now that is some incredibly powerful evidence.
All right, let's move on from the stuff we wear to the explosive evidence left behind by a firearm. I'm talking about gunshot residue, or GSR. It's that invisible cloud of tiny particles that erupts every single time a gun is fired.
So here's the core idea. When a gun goes off, all that residue blasts forward, out of the barrel toward the target. But
and this is the crucial part, a whole bunch of it also gets blown backward, all over the shooter's hand, their arm, their clothes. It's this two-way street that makes GSR such an invaluable piece of trace evidence.
But with GSR, you're literally racing against the clock. This stuff is a fine powder, and it's super easy to wash off or wipe away, so it has to be collected within just a few hours, and ideally less than 2. Savvy investigators will very carefully swab a suspect's hands, paying special attention to the area around the thumb and index finger. Now, the lab results won't say this person for sure pulled the trigger, but they can tell you if that person recently fired a gun, handled one that was recently fired, or was just standing very close by when it all went down.
So we've got all this amazing microscopic evidence: hairs, fibers, GSR particles. How on earth do scientists actually see this stuff and analyze it? Well, they have a pretty impressive toolkit full of high-tech instruments.
I mean, forensic labs are packed with all sorts of complex machines. You've got things like gas chromatographers and scanning electron microscopes that can do incredible things. But you know what's wild? The single most important, most indispensable tool for a trace examiner, the first and last thing they'll almost always use, is the good old-fashioned optical microscope.
And that kind of brings us to our last really crucial question. If most trace evidence isn't a smoking gun like a DNA match, then why is it so incredibly important for solving crimes? Because while a single thread might not solve a case, hundreds of them woven together can create a story that's impossible to deny. Each fiber, each hair, each particle helps to build a web, piece by tiny piece, that connects a suspect to a crime and ultimately reveals the truth.
Thank you so much for joining us for this peek into the amazing world of trace evidence. We really hope you enjoyed it, and be sure to keep an eye out for the next explainer from all of us here at Smart Tutor. We'll see you then.